Hello, I am Ali Maulani and I'm with Ali Dawood. Today we present our title Symmetric Co-Digestion of GCC Biowastes and Data Seed Cultivars. Today we're going to talk about the problem that is Bahrainic Organic Waste Challenge. We have the landfill of Askar is 52.5% of organic waste and have a releasing fugitive of CH4, which is methane gas, risking the groundwater contamination. And our policy in Bahrain is they have the vision for 2030 and 2060 net zero. The demand for renewable energy expansion. Now we're going to talk about the static design. It's a symmetric triple blend system. It has the equal feedstock. Each substrate contributes exactly 3.5 G or 33.33% of total load, which is total of 10.5 gram. Then we have firstly the cooked white rice, high starch of high municipal food waste, fresh cow manure, biological medium, and date seed, which is class and Knevi cultivars. Then we have two independent reactors, A and B, that run duplicate over 21 days at 42 plus minus 1 degree mesophilic conditions. Pre-treatment and biogas train setup. We have selected bioreactor, which is 42 degrees. Then we have the inverted gas geometric capture. Then we have 3M of NOH, CO2 scrubber. Then we have the dead seed were grounded to smaller than 1 millimeter, soaked in 2 NOH for 24 hours to disturb the crystallized lignin fibers post-treatment. Washing neutralizing pH to 7 before the digestion and preventing inhibition of manufacturing cultures. Kinetic modeling modifying compressed equation. We're going to talk about the equation and what have got in the parameters. The Ymax of the class is better than the Khnezi, and it's have the Rmax even better, which is 24.15, which is Khnezi to 19.8. And for the yield days, as you can see, the class will get us more gas in 2.14 days, unlike the Khnezi can take almost double. And the R2 is higher for the class. Batch result cumulative biomethane yield. We're gonna talk about the yield. How many days that it took us to get the maximum yield, which is 21 days until it get us the maximum yield. Class output performs Khnezi by 7.89%, Ymax 31.25 with 289 milligram with much shorter phase, 21.4 days with 33.85 days. Class fibers were highly separated to alkalinization, enabling hydrolysis with high starch rice slurry.
Hello everyone. As a continuation of our presentation, we have a daily fermentation velocity profile, which is for the Khlas and Khanezi cultivars. As the red one is the presenting the Khlas, and the blue one is the Khanezi cultivar. We see a peak of 7 days of 24.15 milliliter per day for the Khlas, and Khanezi was peaked at the day number 10, which having a yield of 19.8 milliliter per day. The Khanezi is denser fiber matrix, resist the NaOH pre-treatment, which is limiting the hydraulic enzyme access and slowing the fermentation. In terms of the scrubber performance, we have as CO2 removal and the thermal profile. For Khalas and Khanezi, which the Khalas started at 25 and the Khanezi approximately at 30, we have the peak gas production at days from 4 to 9, which the scrubber temperature rose 3.2 to 4.8 degrees Celsius above the ambient, confirming high velocity gas formation. And for the methane purity, the 3 molar NaOH matrix maintained CO2 extraction efficiency which will deliver us a purity of 96.5% of pure biomethane at the end of our stage 3 of our experiment by using the gasometer. For our continuous stirring tank reactor, we did a scale-up design for it. We set it at 4 parameters, which is first of all the 10 metric tons per day, which is the waste mixed of 2,200 kilogram per day, and for hydraulic retention time of 20 days. We set the reactor volume. Our target will be operating at 400 meter cubed and safely below 700 meter cube design ceiling. For our energy conversion, we have approximately of pure biomethane at 35.8 megajoule per meter cubed, which can be used for the thermal yield calculations. For our scale-up results, we have steady state outputs, which for خلاص الخنيزي approximately at 687 for خلاص meter cube per day of pure gas methane, biomethane, which is equal to 6.84 megawatt hour per day. And for Khanesi, we have 637.12 meter cubed per day of the pure gas methane, biomethane, which will deliver us at 6.34 megawatt hour per day of thermal energy. In our conclusions, the important things we set as the 2% NaOH pretreatment, which will be effectively disturbed of our lignocellulose defense of both date seeds, the خلاص and Khanesi, and the خلاص will achieve the superior max of 312 milliliter per gram, and with a shorter lag phase of 2.14 days against the Khanesi cultivar. In our scale-up of the continuous stirring tank reactor of 10 tons per day, it will be operated stably within safety margin at 20 days of hydraulic retention time. About the framework directly supports Bahrain economic vision, and we will be using our waste, and the organic waste and the Askar landfill will be supporting the economic vision of 2030, also the 2060 net zero commitment of Bahrain. As for the recommendations for future work, we firstly pilot scale our reactor validation will be 50 to 100 liters of the continuous bioreactor to monitor of our VFA accumulation and the microbial dynamic under real OLR. And we will be testing another pretreatment for optimization as for the KOH and the CaOH2 at 0.5 to 5% concentration to balancing the delignification efficiency against the chemical costs as we sit in our reactor at the NaOH. And for the life cycle assessment and the techno-economic analysis we did, the quantify avoided the landfill emissions, and we evaluated full commercial scale-up and financial viability. And the thermal heat recovery capture exothermic scrubber heat via closed loop exchanger to the preheat incoming feedstocks and reduce parasitic load.